The United States has launched some of the most ambitious, expensive, and flat-out insane space missions in human history. Today, I'm breaking down every major US space mission and everything you need to know about them, starting with the one that kicked it all off, Project Mercury. On October 7, 1958, NASA approved a program that would change humanity forever. Project Mercury had one goal: get an American into space, and they refused to wait. Instead of completing one phase before starting the next, NASA ran everything simultaneously: spacecraft development, astronaut training, tracking networks, all at once. And it worked. Alan Shepard became the first American in space on May 5, 1961. Less than a year later, John Glenn orbited the Earth 3 times, from program approval to orbital spaceflight in roughly 3 years. But Mercury was just the beginning, because NASA immediately looked at what they'd built and said, now let's learn how to actually work in space. Project Gemini. Nobody talks about Gemini, and that's honestly criminal. This program ran 10 crewed missions with 2-person crews between 1965 and 1966, and it solved every single problem that would have made Apollo impossible. Rendezvous? Gemini figured it out. Docking? Gemini 8 pulled off the first ever space docking with an uncrewed Agena target vehicle. Spacewalks without astronauts passing out from exhaustion. Buzz Aldrin logged 5 hours and 30 minutes of EVA on Gemini 12 and proved it could be done. The program even demonstrated nearly 14 days of mission endurance, which was longer than the 8-day round trip needed to reach the moon and come back. These weren't bonuses, they were prerequisites. Without Gemini, Apollo doesn't work, period. But if Gemini was the rehearsal, Apollo was the show that changed human history forever. Apollo program. On May 25, 1961, Kennedy told the nation they were going to the moon before the decade was out. At the time, America had barely put a man in space. The audacity of that timeline cannot be overstated, but they did it. Neil Armstrong and Buzz Aldrin landed on July 20, 1969, with 5 months to spare. The Saturn V rocket that got them there generated 7.5 million pounds of thrust and could hurl a 96,886-pound spacecraft all the way to the moon. 12 people walked on the lunar surface across 6 successful landings, with Apollo 17 in December 1972 being the last. Nobody has been back since. And yes, some people still think it was faked. It wasn't. Physical lunar samples, independent tracking from multiple countries, and the sheer impossibility of faking it with 1969 technology shut that argument down completely. But landing on the moon was never the finish line. The real question was whether humans could actually live in space, and that's exactly what the next mission set out to prove. Skylab. Skylab almost died 63 seconds after launch. America's first space station, all 170,000 pounds of it, rode the final Saturn V rocket into orbit on May 14, 1973, and immediately everything went wrong. The thermal shield ripped clean off. One solar array failed to deploy. The station was overheating, underpowered, and essentially dead on arrival. But here's the thing: ground crews and astronauts refused to let it die. They improvised fixes in real time, rigging a parasol sunshade and freeing the jammed solar panel during spacewalks that were never part of the original plan. And it worked. All 3 crewed missions succeeded, with crews staying 28, 59, and 84 days respectively. They conducted nearly 300 experiments across biomedical science, solar astronomy, Earth observation, and materials processing. Nobody talks about Skylab, but it quietly proved the single most important thing NASA needed to know: humans could live and work productively in space for extended periods. Every space station that came after owes its existence to this underdog program that nearly ended before it began. But Skylab was just a temporary home. What NASA really wanted was a reusable way to get there. Space Shuttle program. The Space Shuttle was supposed to make space travel routine. That was the whole pitch: a reusable spacecraft that would fly 25 to 60 missions per year, turning orbit into a commuter lane. The reality? 135 total launches across 30 years. After 1988, NASA averaged around 8 flights annually. But here's the thing: what the shuttle actually accomplished is staggering. 5 orbiters, Columbia, Challenger, Discovery, Atlantis, and Endeavour, collectively traveled 537 million miles and completed 20,952 orbits around Earth. Discovery alone flew 39 missions, more than any other orbiter. And then there's the cost nobody wanted to pay. On January 28, 1986, Challenger broke apart 73 seconds after launch. 7 astronauts gone. 17 years later, on February 1st, 2003, Columbia disintegrated during re-entry. 7 more. Both disasters grounded the fleet, forced massive redesigns, and left a permanent scar on the program. The shuttle never became the affordable space truck NASA promised, but it deployed Hubble, built the International Space Station, and proved humans could work in orbit for 3 decades straight. Revolutionary and flawed. Both things are true, and speaking of the station it helped build, that story deserves its own chapter. International Space Station, ISS. Here's something that sounds like it shouldn't be real. The United States and Russia, 2 nations that spent decades pointing nuclear weapons at each other, decided to build a house together in space. And then they actually did it. The ISS was born from merging 2 competing programs, America's Space Station Freedom and Russia's Mir 2. Cold War rivals became roommates. Assembly started in November 1998, requiring over 40 flights to piece the whole thing together. The result is about 357 feet end to end, with more livable space than a 6-bedroom house. Since November 2nd, 2000, humans have lived aboard continuously. Over 25 years of uninterrupted presence in space. More than 270 people from 21 countries have visited. Has it been expensive? Absolutely. Over $100 billion total, but the station proved something no experiment ever could, that former enemies can share a home above the planet they once threatened to destroy. With planned deorbiting around 2030, the question now is what replaces it. But whatever comes next has massive shoes to fill, because the ISS didn't just advance science, it rewired diplomacy. Artemis program, 50 years. That's how long it's been since humans last stood on the moon. And NASA's plan to go back is simultaneously the most exciting and most frustrating space program in modern history. Artemis 1 finally launched November 16th, 2022, after 4 scrubbed attempts that tested everyone's patience. But when it did launch, the Space Launch System produced 8.8 million pounds of thrust. That's 1.3 million more than Apollo's Saturn V. The most powerful rocket NASA has ever built. Artemis 2 targets a crewed lunar flyby no earlier than April 2026. Artemis 3 aims for the first crewed moon landing since December 1972. And here's what makes it genuinely historic. Astronauts will land at the lunar South Pole, a region no human has ever visited. The bigger picture is Mars. Every system tested at the moon is a stepping stone for deep space. But the budget has topped $93 billion, and timelines keep slipping at nearly every milestone. Critics argue the lunar detour delays Mars. Supporters say you don't send humans to Mars without proving the hardware closer to home first. The ambition is real. The rocket is real. Whether the schedule holds is another question entirely. But speaking of ambitious missions to other worlds, NASA's robotic explorers were doing the impossible decades before Artemis was even a concept. Viking 1 and 2. Viking 1 landed on Mars on July 20th, 1976, exactly 7 years to the day after Apollo 11 touched down on the moon. And it came with one question that no mission had ever seriously tried to answer. Is anything alive up there? Each Viking mission cost roughly $1 billion, about $6 billion in today's money, and for that price, they delivered. The landers found every chemical element essential to life: carbon, nitrogen, hydrogen, oxygen, phosphorus. They found evidence of ancient river beds and massive flooding, proving Mars once had liquid water on its surface. But here's where it gets frustrating. The soil experiments designed to detect microbial life came back with results that were genuinely ambiguous. Some scientists looked at the data and said yes, those are biological signatures. The broader scientific consensus said no, not definitively, and that debate has shaped every single Mars mission for the last 50 years. Viking 1's lander kept operating for over 6 years on the Martian surface. It gave us answers to questions we didn't even know to ask. But the one question we actually sent it there for, still unresolved. And if you think an unanswered question is frustrating, wait until you hear what Voyager found when it left the solar system entirely. Voyager 1 and 2. In 1977, NASA launched 2 probes that are still alive today. Voyager 2 left Earth first in August. Voyager 1 launched 2 weeks later on a faster trajectory and eventually overtook its twin. Both visited Jupiter and Saturn, but Voyager 2 kept going. It's the only spacecraft in history to visit Uranus and Neptune. Nobody else has even tried. Voyager 1 crossed into interstellar space in 2012. Voyager 2 followed in 2018. Right now, Voyager 1 is over 14.4 billion miles from Earth, and it's still transmitting. Every signal it sends takes over 22 hours to reach us at the speed of light. Both carry the golden record, a gold-plated disc loaded with sounds, music, and images representing life on Earth. It was included on the chance that something out there finds it. And honestly, the question of what you put on a message to the entire universe universe is one of the most human things NASA has ever grappled with. But if you think sending a message into the void is ambitious, wait until you hear about the spacecraft NASA sent to live inside Jupiter's radiation belt. Galileo, on October 18, 1989, Space Shuttle Atlantis released a spacecraft that would completely change how we think about life in the solar system. Galileo spent 6 years just getting to Jupiter, arriving December 7, 1995, and then it stayed for almost 8 more. Over that time, it completed 34 orbits and 35 close encounters with Jupiter's major moons, 11 with Europa alone, traveling roughly 2.8 billion miles total. But here's the discovery that shook everything. Galileo found evidence that Europa, this tiny ice-covered moon, likely contains a subsurface saltwater ocean with more water than all of Earth's oceans combined. An entire hidden ocean buried under ice, orbiting Jupiter. That single finding made Europa one of the most promising candidates for extraterrestrial life in our solar system, and the ending is almost poetic. On September 21, 2003, NASA deliberately crashed Galileo into Jupiter's atmosphere, not because it failed, because they needed to protect the very thing it discovered. Earth microbes hitching a ride on the spacecraft could have contaminated Europa's potentially habitable ocean, so Galileo's final act was a sacrifice to keep that alien ocean pristine. But if you think Galileo's discoveries were groundbreaking, wait until you hear what happened when we finally reached Saturn. Cassini-Huygens. Cassini launched October 15, 1997, arrived at Saturn on July 1, 2004, and then stayed for 13 years, 294 orbits around the ringed planet. But the real headline? This single mission found 2 potentially habitable worlds. First, the Huygens probe. On January 14, 2005, it dropped through Titan's atmosphere for 2 hours and 27 minutes, achieving the most distant landing from Earth ever at that point. And what it found was genuinely unsettling. Titan looked like Earth. Methane rain falling from orange clouds, methane rivers carving channels into the surface, hydrocarbon lakes sitting in basins. It's our planet running on the wrong liquid, minus the water and oxygen. Then Cassini discovered something arguably bigger. Saturn's tiny moon Enceladus was shooting active icy water plumes straight into space. Literal geysers of ocean material erupting from beneath the surface, suggesting yet another subsurface ocean that could support life. On September 15, 2017, Cassini dove into Saturn's atmosphere and burned up. Just like Galileo at Jupiter, it was a deliberate death to protect those potentially habitable moons from contamination. But if you think Saturn's secrets were wild, wait until we get to what a nuclear-powered rover found crawling across Mars. Mars Science Laboratory. Curiosity. NASA sent a nuclear-powered SUV to Mars and landed it with a jet-powered sky crane. That sentence sounds made up, but every word is true. Curiosity launched in November 2011 and touched down in Gale Crater on August 6, 2012. The rover weighs about 2,000 pounds and stretches 10 feet long. But getting something that massive onto Mars required the most insane landing sequence ever attempted. Engineers called it the 7 Minutes of Terror, a 15-step automated sequence where a single failure at any point meant total mission loss. The finale involved a hovering rocket platform lowering Curiosity on tethers like some kind of alien construction crane. It worked flawlessly. The original mission was 2 years. As of early 2026, Curiosity has been operating for over 13 years and driven more than 22 miles across Martian terrain. But the real payoff is what it found: organic molecules preserved in rock layers 3.5 billion years old, variable methane levels in the atmosphere that still can't be fully explained. Not proof of life, but exactly the kind of chemistry that keeps scientists up at night. But if Curiosity opened the door, the next rover kicked it clean off the hinges. Mars 2020 Perseverance. Perseverance landed in Jezero Crater on February 18, 2021, and it brought a friend. Ingenuity, a tiny helicopter, was supposed to complete 5 test flights over 30 days. It completed 72 flights before its final landing on January 18, 2024. That's one of the most spectacular overperformances in NASA history, but the rover itself is where things get serious. Perseverance has collected over 24 rock samples sealed for a future Earth return mission. It demonstrated oxygen production on Mars using the MOX-IE experiment, directly testing technology humans will need to survive there. And then in July 2024, it found a rock called Chayava Falls containing potential biosignatures. Peer-reviewed analysis published in Nature validated the finding as the first credible indication of possible patterns past microbial life on Mars. Let that sink in. We might have found evidence of life on another planet, but if Mars is exciting, wait until you hear about the mission heading to an ocean hidden under ice. Europa Clipper. Remember everything Galileo hinted at with Europa? The subsurface ocean, the potential for life, the tantalizing data that left scientists desperate for more? NASA finally built the follow-up. Europa Clipper launched October 14th. 2024 on a Falcon Heavy, and it's the largest planetary science spacecraft NASA has ever constructed. Here's the thing, you can't just orbit Europa. Jupiter's radiation would fry the spacecraft in weeks, so NASA designed something clever. Europa Clipper will conduct 49 close flybys, dipping as low as 25 kilometers above the surface before swinging back out to safety. Each pass builds a more complete picture without cooking the instruments. But here's where it gets genuinely mind-bending. The spacecraft will attempt to fly directly through Europa's water vapor plumes. That's ocean water erupting through miles of ice into space, and Clipper is going to taste it. No landing required. Just an alien ocean sampled mid-flight. It arrives at Jupiter in April 2030, and if those plumes deliver what scientists hope, we might finally answer whether we're alone in this solar system. Hubble Space Telescope. On April 24th, 1990, the Space Shuttle Discovery carried what was supposed to be NASA's crown jewel into orbit, a 2.4-meter mirror designed to see the universe with perfect clarity from 600 kilometers above Earth. There was just one problem, the mirror was wrong. A tiny spherical aberration turned every image into a blurry mess, and the entire world watched NASA's billion-dollar telescope fail in real time. It was humiliating. But here's where the story gets good. In December 1993, astronauts performed 5 spacewalks to install corrective optics. They literally gave a space telescope glasses, and it worked. Overnight, Hubble went from punchline to legend. Since then, it's made over 1.7 million observations. Its data has fueled more than 22,000 scientific papers cited over 1 million times. The Hubble Deep Field, the pillars of creation. These aren't just images, they're cultural landmarks that changed how humanity sees itself in the universe. A telescope designed for 15 years of service became immortal, but Hubble wasn't the only observatory NASA launched into orbit, and the next one hunted something far more violent than starlight. Compton Gamma Ray Observatory. Nobody talks about this mission. And honestly, that's criminal. In 1991, NASA launched the Compton Gamma Ray Observatory aboard Space Shuttle Atlantis, and at 17 tons, it was the heaviest scientific payload ever flown on the shuttle at that time. Cost $617 million. And what did it do? It detected the universe exploding every single day. The BATSI instrument on board picked up approximately 2,700 gamma ray burst events over the mission's lifetime. That's roughly one cosmic explosion per day for 9 straight years. But here's the thing, before CGRO, scientists assumed most of these bursts were coming from inside our own galaxy. We're releasing more energy than our sun will emit over its entire 10 billion year lifetime. Let that sink in. One flash. More energy than 10 billion years of sunlight. CGRO operated until 2000 before NASA intentionally deorbited it, and its discoveries directly led to the Fermi Gamma Ray Space Telescope in 2008, which continues hunting these explosions today. But if gamma rays reveal the universe's most violent moments, the next telescope on this list reveals something equally mind-bending, just in a completely different wavelength. Chandra X-ray Observatory. Most telescopes show you what's shining. Chandra shows you what's dying, colliding, and falling into oblivion. Launched July 23, 1999 aboard Space Shuttle Columbia, this X-ray observatory orbits Earth in a massive elliptical path that swings out to roughly 139,000 kilometers, more than a third of the way to the moon. That extreme orbit keeps it above Earth's radiation belts for uninterrupted observations, and the optics are insane. 4 pairs of nested iridium mirrors focus X-rays at incredibly shallow angles, delivering 8 times the resolution and detecting sources 20 times fainter than any previous X-ray telescope. That precision confirmed the supermassive black hole at the center of our galaxy by capturing X-ray emissions from material spiraling into it. But here's the showstopper. Chandra watched 2 galaxy clusters slam into each other and observed something nobody had ever directly seen before. The hot visible gas slowed down from drag, exactly as expected, but the dark matter passed straight through completely unaffected, physically separating from normal matter in real time. That's as close to seeing something invisible as science has ever gotten, and it remains some of the strongest direct observational evidence for dark matter's existence. But if Chandra revealed the universe's hidden violence, the next telescope revealed its hidden origins. James Webb Space Telescope, JWST, $10 billion. That's what was riding on Christmas Day 2021 when an Ariane 5 rocket launched the most expensive scientific instrument ever built into space. But here's the thing, unlike Hubble, nobody could fix this one if something went wrong. JWST was heading to the L2 Lagrange point, 1.5 million kilometers from Earth, way too far for any repair mission, and the telescope couldn't launch fully assembled. It had to unfold itself over 30 days, 18 mirror segments, a 5-layer sunshield the size of a tennis court, 344 single points of failure. If any one of them failed, the entire mission was dead. Every single one. Worked. By July 2022, JWST released its first science images, and they were staggering. This telescope sees in infrared, meaning it can look 13.5 billion years back in time to the first galaxies that ever formed after the Big Bang. It's already rewriting what we thought we knew about early galaxy formation, exoplanet atmospheres, and the structure of the cosmos itself. But if peering back to the birth of the universe sounds impressive, the next telescope NASA is preparing might reshape how we understand everything closer to home. Earth Observing System, Terra, Aqua, and Ara. Nobody talks about these satellites, and that's insane because you probably use data from them today without even knowing it. Terra launched in 1999, Aqua followed in 2002, Aura came in 2004. 3 satellites, 5 years. And together they quietly became one of the most important space programs NASA has ever run. Terra monitors land surfaces and atmospheric conditions. Aqua measures literally every variable in the global water cycle. Aura tracks atmospheric composition, including ozone and air quality across the entire planet. Between them, they cover all 6 of NASA's Earth science focus areas simultaneously. The MODIS instruments aboard Terra and Aqua image the entire Earth every 1 to 2 days. Every 1 to 2 days. But here's the thing, weather forecasts, hurricane tracking, wildfire monitoring, decades of climate research, all of it relies on EOS data. These satellites are the backbone of how we understand our own planet, and they're basically invisible to the public. And if you think watching our planet is impressive, wait until you see what NASA built to hunt for planets we haven't even found yet. Nancy Grace Roman Space Telescope. Every mission we've covered in this video built toward this moment. The Nancy Grace Roman Space Telescope completed construction on November 25th, 2025, and is scheduled to launch no earlier than September 2026 on a SpaceX Falcon Heavy to the L2 Lagrange point, right alongside James Webb. Here's what makes Roman special. Its primary mirror is the exact same size as Hubble's, 2.4 meters, but its wide field instrument provides a field of view 200 times larger than Hubble's infrared camera, capturing 300 megapixel images across massive stretches of sky simultaneously. In its first 5 years alone, Roman is expected to discover tens of thousands of new exoplanets through gravitational microlensing, detecting distant worlds by watching how their gravity bends starlight from background stars. That's more exoplanet data in months than Hubble gathered in decades. It will also carry a technology demonstrating coronagraph to block starlight and directly image a small number of mature gas giant exoplanets, while the wide field instrument simultaneously maps dark energy across cosmic history. 2 of the biggest open questions in astrophysics, tackled by one telescope. And the name matters. Nancy Grace Roman was NASA's first chief of astronomy. She spent her career fighting for the funding and infrastructure that made the Hubble Space Telescope possible, a telescope she never got to see launch. Now her name is on the next one. The story of US space exploration isn't over, it's accelerating. If you enjoyed this video and want to see more, click the video on the screen now.